Okay, the moment of truth has arrived. Time to see the capacity of these cells. So I'm afraid all I have is state-of-the-art testing equipment. I have this little energy meter and I have a 300 watt pure sine wave inverter. It's showing 13.98 and this has 13.9, so yeah, and the USB is 13.9, so everything looks good there. I looked around to see what I have to put a bit of a load on. I don't have much. I came across this nasty looking instrument. It belonged to the girls for their hair, and it has 140 watts, so that'll give me 140 watts. Test is underway now. It's on for about a half an hour, and I'm just taking some basic readings as I go along while it was at rest. Cell voltages and any other relevant information. 138.2 and 10.7 amps. Yeah, 10.83, 139 watts as against 132.8, so things are fairly similar. The voltage is quite different on this one. That's showing 12.77 volts, and this, with these small cables, I'm losing a bit because the you can see it there. The USB is 12.9, which is close enough to that. So yeah, I could be losing a bit in the small cables here. Temperature is gone up 1 degree since we started. It was 12 at the start. We're at 80% now and everything is looking very good. The cells are looking good. Only a differential 0.007 temperature is good. I've checked all the temperatures around, they're all steady. Yeah, 12.77, and we're getting 13 volts. There's definitely a drop there. This is a bit warm, this cable, but this is a 20 amp energy meter. But I don't know why they always make small tiny lugs, terminal lugs. That's the biggest cable I can fit in there. I don't understand this average volt. I mean, the maximum and minimum are above it, and all the cells are above it. So where do I get 3.25? But the differential is very good. I can see an advantage straight away of this lithium iron phosphate against the lead acid, and that is it can maintain the high voltage. The problem I find with the lead acid, if say you have a 12 volt DC fridge or a bastard diesel heater or certain electronics, when they sense the voltage coming down to say 12 volts, they'll go into shutdown. I mean, you can lose 0.2, 0.3 in the cabling no matter what economical size you have. So straight away I can see an advantage here, that you could have multiple starts and still maintain 13 volts or 12.8 or whatever it might be. So that's a plus of these type cells. We're down now to the 60%. We just dropped below the 60% and she's just dropped to 12.9 volts and 10.6 amp, and all the cells are still looking very good. So everything looks quite steady. The cells are very good, the differential is very good. We've come up a slight bit in temperature and we've just dropped now down to 12.9 volts, and we have 383 watts. So operationally now she's met my needs. What's that, about 26 ampere hours there already. The most I would use any day now would be 15 ampere hours. So I could go 3 to 4 days without solar if it's foggy, misty. a rare event before I'd have to consider charging the from the mains. It's good to know there's a reserve if we have a power outage for charging phone, batteries and running a few LED lights. So we'll carry on now, but operationally she's met my requirements. Right, we're at just gone beyond the 30% now, and yeah, everything is looking okay so far. Cells are still well balanced, temperature's holding steady, and yeah, we're at 651 watt hours. Next stop now will be the 10%, and I take it the BMS will shut it down at that. So I'll just talk about the cost. The base cost, if you consider delivery of the cells, the BMS and the battery box, came to €340. And then I had the ancillary and the consumable items, what you consider, you know, the various tapes, fuses, fuse holder, lugs, battery isolator, all those bits and pieces, plus the ancillaries of, I needed to get a LifePo4 battery charger and the ISDT Q6 balancer. I won't include the Amazon Basic torque spanner. I went back for a refund. But all that additional came to €210, giving me an overall figure of €550 for the complete installation. Now, for €550 I could get 100 ampere hours deep cycle batteries or 2/3 AGM batteries, which would give me more capacity. So that brings up the old question. Now I know a lot of people are knocking the lead acid and saying it's finished. I don't think so. You take petrol cars, diesel cars, trucks, I would think the lead acid battery is ideal. I know for these cells they talk about 10, 12 years or more, but who's going to keep a car more than 5 or 6 years? I would imagine anyone who has a big shed or workshop of that and can store the likes of AGM and that, and have a solar array, you would have to work out the cost. The lithium iron phosphates have advantages, and one of course would be the weight. If you're camping or caravanning, makes a big difference. The other, of course, is the maintaining the voltage, as I talked about earlier. If my memory is right, and I could be wrong now, that for lead acid the rating for capacity is at 25 degrees C, and I read somewhere that if you go down to say 10 degrees C, you reduce the potential energy of the battery to 50 to 60%, and if you go down to 0 degrees C, it's even less. Now I know the car starting batteries have this called cranking amps, but I don't think the LifePos would suffer the same as the lead acid. I could be wrong. Okay, we're down to 10% now. Clearly my state of charge meter is not correct yet. It needs calibration. I suppose I have to get discharged and then a recharge. So there's still a bit in there yet, but I believe on the discharge curve, when you start getting down in voltage, it can fall off quite rapidly. But capacity spec was 896, so we seem to be getting quite close. Yeah, so I have noticed the temperature has come up to 17 degrees. Now these state of charge level 1 and level 2 are coming up. I don't know what, that must be in the program, but they're all fairly well still over 3. The differential is starting to go up now. 19 volts, so I'd say we're getting close to some situation. Intended use for this battery, I have a Chinese diesel heater that's pumping in hot air into the front room. There's a deep cycle battery seconded at the moment to do that job, so I'm going to use this battery for that job. It should be better for holding the voltage, as I spoke about earlier. And then in the off season, the summertime, I have a friend of mine, a buddy, that needs a CPAP when we go on trips, so it will be used for that. And my laptop has the cable to connect to 12 volt DC, so it'll do that function as well, and phones and that. So that's the intended use, but demand will not be big. The voltage is coming down now and the amperage is going up. Yeah, I might give it another little bit, but so far it's looking good. I'd say we're getting close now. The differential is going up there now, and I would say cell number 2, what's that? Cell number 2, I'd say, is the one that's either that's going to trip it, or I'm getting close to my setting of 0.25. But that's an alarm on that for low voltage. That's that thing. So we're getting close, but she's still 11.3. Which is going to come first, the 2 point that or this fella? Right, she's just tripped on this number 2 cell, and that's my readings there. But the voltage still hasn't gone down to yeah, so number 2 cell is bringing her out. So there we are, bringing her down, but you can see we still have a good bit of voltage to go. I suppose if I set them a bit lower, but yeah, so the bottom balancing I'm not going to bother about. The top balancing is excellent. I'm very impressed with how she went all along, just till we got to the very end. It started to go up. So therefore I reckon 6.5 hours, or take an average of 10.7 amps, the 70 ampere hours is there alright. I reckon that taking off the 24 that I had in the meter, so that's what, 860 say, and the total energy in the mod should be 896, and clearly there's more energy there, because I'm not down to the 10 volts. So I'm happy. As I say, I won't be I can't see me going below 60% normally. Now there are those, no doubt, who will find holes in my methodology for capacity testing, but this will be very good for me as a baseline reference, especially for cell difference, and temperatures was excellent. I now have an understanding of the of these cells, and I'm convinced that they are over the 70 ampere hour rating. If I went down to 10 volts, if I adjusted the low setting there, no doubt I'd get there is more in her. But 6.5 hours, I've taken an average of 10.7 roughly now, taking 10.7. That would give me my 70 ampere hours. In the energy, there will be a bit left there. About 36 watts, and I'd say that's definitely there. So overall, very pleased. So Shin scale, I'm happy enough. No heat from anything. Everything is normal enough. I take it I have to maybe when I charge up now recalibrate this this fella. But I'm nowhere down to the 10 volts. But that's the bottom. That's number 2 cell. But for most of the way down, they were perfect for what I'll be working on anyway. My area there, the differential look 0.05, 0.07, 0.06. So that's it. Shin shin.